So, hello everyone. Machine learning in Python programming, part 3. We continue our data pre-processing steps. In the part 2, we have seen some data pre-processing steps that we just very quickly. Yes, so in the part 2, we have covered the data cleaning techniques. There are three techniques: MCAR, MAR, or MNAR. So here in the part 2, we have seen that how to collect the data. So this is a whiteboard. So we use whiteboard marker, and on that whiteboard marker we attach the IMU sensor for collecting accelerometer, gyro, compass values when a student write on the whiteboard. So here we can see the English characters K, L, M, N. When we write on the whiteboard, we can collect the 9 axis values: accelerometer, gyro, and compass. And this is some sample for outcome that small z indicate the character that write on the whiteboard. This is the date on which date we have collected. This is the time stamp, and this is the accelerometer, gyro, and compass. This last one indicates that the value continuously recording in this, and 0 indicate that okay, the stop it at this point, and there is no recording at this point. So this is the random motion of this pen, and here when they write on the whiteboard the z character, that indicates the 1. So with the help of this we can do the pre-processing, and that means the cut the time series at a particular level in this way. But when we collect the time series, numbers of pre-processing steps are required so that we can filter out the noise, we can prepare the data for the machine learning. So in the part 2, we have already covered that data cleaning techniques. So there are why we are required the data cleaning technique. We have highlighted that missing values, remove the outliers, and inconsistency is there. So that all these things we have seen in part 2. Now today we come to the part 3. So in the part 3, that data integration. So that means it is very tough to collect all the data at the same source. So what we need to do, the data is in different places, and we need to combine the data. So the process, so data integration in the pre-processing is the process of combining the multiple data sources into a single comprehensive data sets. So the advantage of such a multiple data sources is that no processing, multiple devices are there, they can do all these things, and finally we can combine all the data at a single place. And it combined data helps to improve the accuracy performance of the model by providing more data and different perspectives. So say for example, when you write on the whiteboard, you also use the other sensors along with the accelerometer, gyro, compass, some pressure sensor, some sort of things. And Python support various ways, several ways to perform the data integration, especially concatenate, merging, and joining. So in the concatenate, multiple data sources horizontally row-wise or vertically column-wise concatenate to form a single data set. So here in the concatenate, there are two ways: either you can do the horizontally or you can do the vertical. In the horizontal, that row-wise we can concatenate, or vertically we can concatenate the column-wise. So this is an example code, and we try to run this code on Google Colab, so that we can check the outcome and what is the output of this program. So I copy this program, and this is my Google Colab notebook. Copy and paste it here in this code. But here in this code we use the data.txt file. One file is there which is in the content file. So this is the Google Colab folder, and here we have the temporary space where we can put the this file data.txt. So this data.txt file is that we have seen that collected data, that z is the value and time stamp and accelerometer, gyro, compass. So I have already downloaded this file in my download folder. So we select it here and do it. So they say that okay, this is the runtime file will be deleted when the runtime is terminated, because this is the temporary space. So you have seen this type of the warning. If you want to do either permanent, you need to put in this your folder drive, then this file can be go in a permanent fashion. So this is the file, and if you want to check that what is the copy the path, if you copy the path and check that what is the path of this one, this is the path of the file. So that is the same as that we have already written. Now they can successfully take this file. So if you want to see the file, we just click it here, and we can see that okay, this is the file, that accelerometer, gyro compass, whatever the values that we have seen. But this is a very long file, huge file is there, numbers of rows and columns are there, so it is very tough to work on these rows and columns in this sample code. So here what we have done, we extract some portion of the code. So first I just try to explain this program, what this program is doing. So first two lines, pandas and numpy of the code, import the pandas and numpy library and create the alliance for PD and NP respectively. Now in the future, pandas you can use as a PD, numpy as a NP. Now the this third line of the code, whatever this one code is there, so this helps to load a real world data set from a text file using the pandas read CSV file. So this is the pandas library, that function is there in that library, pandas library. The file is located at this location, and header equals to none indicates here that there is no header row in the data. So there is no header row, directly data comes from the row 1. So if we write on before the row 1, if we write that okay, this is the character, this is the type stem, like this one, then we are not able to write the none. So now they assume that the row 0 itself is the data. So now here in the fourth line of the code, create a new data frame. This is the data frame DM, that is the subset of the original data, and so this is the subset of the original data, whatever the data you have collected here. Especially it select the first 5 rows and 2 to 4 column. So 5 indicate that you select the 2, 3, 4th number column, and 0 to 5 indicate that the row 0, row 1, row 2, row 3 and row 4. So 5 rows, and there are 3 columns that you have selected, that 2, 3 and 4. Similar as the this one line, that this is another data frame, and here you can take the more rows, that 3 to 10th number row. So 3, 4, 5, 6, 7, 8, 9, 10 rows, and 4 and 5 number column. And here you can print the values, whatever the values you have extracted here, and now you can use the concatenate. So here you use the x equals to 0. So this line of the code is horizontally concatenate because you use the x equals to 0. That means this is the horizontal concatenate should be done by the horizontally, and the result concatenate data frame is printed in the console, because you also use the console print here. If you use only that one, then that is only the concatenate, but here you can print the output. And the finally last line indicate that okay, you can concatenate data 1 and data frame 1 and data frame 2 in a vertical fashion, so that here that is the 1. Now we can run this program and see that what is the outcome of this program here. So you can see that the program, this is the 0, 1, 2, 3, 5, 4, 5, 5 rows are there, and 2, 3, 4 columns are there. This is the print for the data frame 2, 4 and 5th number column is there, and 3 to 10. So you can see that the 3 to 9 rows are there, and this is the printing. Now you can concatenate with respect to the 0, as we already seen that the 0 means this is horizontally. So you can see that 2, 3, 4, 5, 6. So they merge horizontally 2, 3, 4, 5. Now 5, 4 is the horizontally different values. So what they have done here, they put one after another. This is the 4th number 1, and this is the remaining 4th, whatever the 4 is there. Now some values are not available because 2 and 3 are not available in this. So what they have done, they have in the NN null values and the null values. So and similar is the 5th number, they also have no values here while doing the concatenate. So there is the NN value, none values. So this is the concatenate helps to auto filling the value with respect to the none, and we already seen that how to handle the none values with the help of average, mean and other things. And another one is that is the vertical. So here you can see that this is the vertical concatenation of the values in that case. So this is all about that how to do the concatenate in this data integration. Now the second one is the merging of the data. So in this case, merging data source based on the common columns or the key. So here you need some column which is the common in both the data sets. So we copy this program once again, the similar as the previous one, and we paste it here. So this almost everything is same that we have seen that here. Here only the difference is that merge data frame 1, data frame 2, and the left one we take care about the column 0, and here we take care about the column 0 of the data frame 2 and data. So this is our sort of thing, the common key, and we merge according to this common key in data frame 1 and the data frame 2. So this line of the code perform a merging operation here, we can say, on two data frame 1 and the data frame 2 using common colon, and the result merge so this is the merge.df, this is the merge data frame will contain only the rows where the value of the specific column matches. So if this column matches values, then only they print this row, otherwise they discard it. So if we try to understand more about this one, so here df.merge is the function that is the pandas library pd that we have used, and used to merge the two data frames, one or more columns. And the first is the data frame 1, data frame 2, and this one is indicate that the left on perimeter specify the column in the left data frame df, left side of the data frame when you are merging, to use the merge operation. And in this case we consider the column number 0. Here is the right side of the data, they also consider this is, and here we consider the column number 0 of the right side of the data. So once you try to run this program, you can see that this is your data frame. So here you can see that we select the same column for this one, data frame 1 and data frame 2, so that we can find out the common in the both cases, otherwise it is very tough to common. Now here we can see that some rows are also overlapping, so 0 1 2 3 4 and 3 2, so 3 and 4 number rows, this is the common in both the data frames. So as per the merge operation, so what they have done, this is the left side, so this is your left side data frame, this is your right side data frame, and they find out with respect to the 0 column, with respect to the 0 column you try to merge, that means the column 2 and the column 2, and find out the common rows. So this row is not here, that is also not there, that is also not there, this row is present in both, so they try to merge 3 4 and 3 4 together. So here you can see that this is only the result. So why? Because they consider this row and they also consider this row, and they put this one as at x, that means the left side, and this is at the right side. So this is all about the merging in the data integration preprocessing in Python programming. And this is the last one, how to integrate the joint operation. So we are so in the that means Python also support the joint operation while merging the data. So while integrate the data with the different sources. So here we can see that this is an interesting line, the joint. So this line join the two data frames, data frame 1 and data frame 2, along their indices using the joint operation, because this is the index basis indices, and then print the results. So here we can say that when joining two data frames, pandas attempt to match their indices. In this case, since the data frame 1, data frame 2 were created using different subsets of the rows from original data set, their indicate may not be perform align. So that means if they are the different, then it is very tough to find out the align. But if there are something is common, then definitely they will print. So you can see that here we have the column 2 and 3, and here we have the 4 and 5 column number. So this is a 2 3 4 5, and the row, if you can say 0 to 5 and 3 to 6, so some rows are common in both. So these rows and that one rows are common in both the cases. So here you can see that this is your result, that 1 9 4 6, this one is the complete result of, because data frame 1 dot join with the data frame 2. So this is the data frame 1, that is your complete data frame like this one, and this is the data frame 2 because you joining the data frame 2. And what is the common is only these two rows are common. Here we can see that third and the fourth values, but the column is the different, but row are the same. So these rows are there, so we can find out these rows. So here we have these rows, and of course these values are not there, that's why they put the null. So this is a index basis. So when you want to join the index basis, definitely we can use the joint operation in place of the earlier one, that merge and the concatenate operation in that case. Now we talk about the another data preprocessing technique, which is the data transformation. So very first question comes in the mind, why data transformation is required. So data transformation is a step to convert the raw data into a more suitable format for analysis purpose, so that you can convert the data in a more effective fashion. So say for example, if the data size is very large, in that case you want to convert the data in a given range, Or if the data is the float values, but the float value operation takes time, so you can convert or transform the data in an integer fashion. So that type of steps are involved in data transformation, and there are two techniques are there. One is the normalizing numeric data, and other one is the encoding categorical variables. So scaling or the normalization numeric values, so transfer the values of the numeric features to a column scale between 0 and 1 or minus 1 and 1. So whatever the values are there, you can transmit in a one given range. The range is 0, 1 or minus 1 to 1, and they ensure that all the features are equally important in the model. So say for example, if you have one data set, they have the multiple columns. One column is the temperature, their values is say for example in Delhi the value is up to 45-50 degree temperature, like this one, and the another is you are consider some accelerometer gyro compass value, so that is the float value like minus 2g to 2 plus 2g. So how we can take the equal importance of these two columns? If we do the normalization and all the value comes range between 0 and 1, then both columns are equally important in that case, whether it is the temperature or it is a temperature, pressure, or IMU sensor values. All columns are important or equally important if they comes between the range of 0 and 1. So this is a very helpful for data transformation, and there are two techniques are there. One is the min-max scaling, other one is the Z-score. So this is an example of the min-max scaling. So similar is previous one example, we consider the same data file and do the min-max scaling. So here we just see the some important point about the min-max scaling. So it preserves the relative differences between the data points while ensuring all the features are on the same scale. So whatever the importance of this data versus this data, they can also preserve while importance of the column wise column, and it can improve the conversion rate of the gradient algorithm. This is very important as it helps to avoid the large step size. So here we can see that the jump is the very large. So say for example, the value jump is that 3.6 is to 5.13. So the difference of the values are very high. So in that case, maybe possible the jump is very large. So the accuracy in the gradient is very tough. So and the conversion rate is also very slow. So but if you use between 0 and 1 all values, they are very close with each other, and you can improve the speed of the algorithm. So once first we copy this program here and we try to run on Google Colab. So this is copy and paste. The file is the same as that one, and we try to run it and see the result. So when you run it, that you can see the column number 3, 4 and 5, the original value is like this one. So once you use the min-max scaling and fit this one of F1, so this is your F1 frame, data frame 1, which is the sub portion of the original data DF file. And once you use the transform, which type of the transformation or scalar you have used, min-max scalar you have used, and transform. And so here when you convert it, then this is the another data frame, which is the transform data frame, and print the original and the transform data frame, and all the values comes between 0 and 1. So this is all about the min-max scaling. Similar is min-max scaling. Another is the Z-scale normalization. So here Z-scale normalization is each value in the data frame by subtracting the mean of the column and divide by the standard deviation, so that all the values comes within a given range and effective. So similar is the previous one. If we copy this program and paste it here, then you can see that. Yes. So the changes is only this one, that you have applied that Z score. So this is the data frame 2 that apply the Z score and find out the value. So this is all the values which is that is subtracted by the mean and divided by the standard deviation. So all values comes within a given range. So this is the data transformation steps, that how to transform the data in one form to the another. And this is another step, that data reduction in data pre-processing. So sometimes data is very large, so it is very tough to handle the all the data, and processing point of view, time complexity, space and computational complexity point of view. So data reduction it helps to reduce the size of the data. It helps to reduce the number of elements in that data. So reduce the number of features of the observation in the data set to improve the performance of machine learning models. And there are two techniques are there. One is the principal component analysis technique, another one is the recursive feature elimination. So PEC is a very common, PCA is a principal component analysis, is a very common approach, and they identify the underlying structure in the data and projected it onto a smaller number of dimensions, while still remaining the much of the original variation in the data as possible. So they reduce the number of columns, and but yes, it is not means that overlap or remove the importance of the data. So whatever the originality is there, that is there, but they remove the unnecessary or some redundant columns are there, so they can remove and reduce the size of the data. And RFE method is the recursively remove the least important features from the given data set until a specific number of feature is reached. So this is the recursively they remove, and here they can remove the dimensions of the data set itself. And this is an example of the PSC, that how the principal component analysis, they analyze the principal component, whatever the columns are there, and they reduce the number of columns, whatever the columns are not required, which is possible in that case. So here we use the CSV file open, that's where they have some error, so we can use the text it here, and then we can run it, and it's run perfectly. So you can see that this is the your original data, and after data reduction, that now you have the only the two columns, and this is the reduced data set. So reduce, but they have their importance. Whatever the features you have created and use the machine learning model, if you create the features and use the machine learning model, that gives the almost equal accuracy, but the size of the data is the 2/3 as compared to in place of the three columns, you have the two columns. So you have reduced the size of the data with the help of this one. So this is all about the principal component. And finally, last step, when you go to the data pre-processing, the data decentralization. So decentralization convert the continuous variables into the categorical value by dividing the range of the variables into the final number of intervals. So say, assume that you have the some grading system is there in your class. So if student marks comes between 50 to 100 marks, so and the grade is A minus, B minus, or some sort of things, C minus. So this is known as the data decentralization. So convert the marks into the grade is the data decentralization. Decentralization. So what is the advantage of this one? So reduce the number of values a variable can take, simplify the data, and improve the performance of certain machine learning techniques. So here we can see that assume that what if the income is there. So income has the range between, say for example, 0 to 10, and we can say we want to categorize the income in subclasses. So one is the low income, one other one is the middle. So if your income is less than 2.5, you can say this is the low income. If your income is 2.5 near, that is the middle income. If your income is the 5, then your income is the high income. And if you 7.5, that is the very high income sort of thing. So this is the way that how we can categorize the income into the subcategory like this one. So that is the way that we can do like this one. And so what is the advantage of this one? This advantage is that now your machine learning can take care about only these 4 or 5 labels. They are not working with the floating value, not the continuous value. So you can reduce the time complexity in terms of this one, and also find out a good accuracy. Similar is the grading system in the class. If we give the 60 to 70, the grade C or grade B is there. So all students, those they have the 60 to 70 marks, they have the grade B. So it is very tough. It is very easy to categorize the student as compared to marks based. Otherwise, all the students they have the different marks. It is very tough to make a group. So this is all about the data pre-processing in machine learning. So before we use the data, we need to do the data pre-processing. So here we can summarize the data pre-processing. Initially, your input is the raw data, whatever the data your sensors collect, and very first you need to use the data cleaning, so that fill the missing values, identify or remove the outliers. Some value is completely out of box because of some garbage or random values like this one, and resolve the inconsistency if any consistency is there. And the second step is that after data cleaning, you go to the data integration, where you use the concatenation, merging, or the joining operation. Then comes to after the data integration, that merge all the data set together and there is no missing value. Then transfer the data in a one form to the another, so that you can speed up your process or normalize the data. Once that speed up the process and you normalize the data, you can use the data reduction. Now you reduce the data because you already integrated, design a huge size of the data and other things. So there are two techniques. They reduce the data, but keep in mind that they reduce the data but not their accuracy. That means whatever the important components are there, so the that columns are there, they are making as it is. So that means they are not compromised with the accuracy in that case. And finally, last one is the data centralization, that convert whatever the reduced data into some category sort of thing, so that you can speed up your machine learning or deep learning models. So this is the 5 step. After these 5 step, you have the process data that you can easily use for your machine learning purpose. So this is all about the data pre-processing. In a very summary, we present the data pre-processing. After that, this is a complete example of data pre-processing where we consider all the steps, whatever the, so very first you call the pandas library, numpy library, then pre-processing, sklearn library, decentralized purpose or the PSC model that sklearn, and the min-max scaling also sklearn library in the preprocessor decomposition. And this one, you need to select the data from your drive, and this is the CSV data. Then you can take some part of the data that you, because you are not able to work the entire part of the data. So first, this is the text file, convert into the CSV. We use the data convert to CSV and select some portion. Then use the data cleaning. Here you can remove the missing values or null values at this point. Then you can merge the data integration. That means we merge the same data with 2 times, so that final data is this one. We can print the data, and then we can do the min-max scaling so that we can scale up or change the scale of the values in this. Then we use the transformation that transform the data with the help of min-max, so comes in a one given range. Then you need to reduce the size of the data, use the PSC. Then change the category of the data, categorize of the data, not floating values. You want only the 4 categories in the data. Once you categorize the data, then you can do the pre-processing, and finally this is your CSV file, that pre-processed file that you can use for machine learning purpose in the future. So this is all about the all together that what data pre-processing is there in your machine learning. So we stop it here, and the part 4 we start the machine learning introduction and the classes of the machine learning and the techniques of the machine learning.